Hello, I'm Eloise Sheiko and I'm delivering the professional learning session on fractions across the primary school. The agenda for tonight is why I've chosen fractions. I'm going to look at the pedagogical content knowledge for fractions, the curriculum links and outcomes from K to 6, the specialised content knowledge looking mostly at language, links to other areas of mathematics and why fractions are important, some common misconceptions that students have, and approaches to teaching and learning. Why do we need to improve the pedagogy of fractions? Fractions is the first abstract concept taught in mathematics. Prior to this, students have dealt with whole number and now they are being exposed to parts of things, so parts of a whole. It's the best introduction for algebra in primary and lower secondary school. This is because the ability to efficiently manipulate fractions is vital to a dynamic understanding of algebra, and the basis of algebra relies on a clear understanding of equivalence. Teacher confidence is generally lower in teaching fractions compared to other areas of mathematics, and students are still finding this concept difficult, and this is evident in testing, such as the NAPLAN results. So looking at NAPLAN results for fractions, I've got this from the Queensland Curriculum and Assessment Authority, but it's looking at the national percentages. So in Year 3, solving a problem including multiples of 1/2 was just under 63% correct. When they're looking at calculating a fraction of a whole number, it ends up being about nearly 68%. And then when we look at solving a problem involving the complement of a fraction, so the complement of a fraction refers to how many parts are in a whole and how many parts to count, that's actually less than 50%. And then when we move to Year 5, we've got, it identifies a quarter of a whole subdivided into 8 parts, just under 70%. And we're looking at represents numbers to 3 decimal places on a number line. So that moves right down to 20.35%. So when we're looking at the pedagogical content knowledge, it's divided into 2 sub-areas. We've got subject matter knowledge and pedagogical content knowledge. So that refers to the common content knowledge, which is the general population. I'm not going to touch on that today due to time constraints. We're also looking at the horizon content knowledge, which is the curriculum across the stages, specialised content knowledge, looking at language and other connection to other areas in this presentation. And the main focus for me and for the handout and to give people the knowledge is the pedagogical content knowledge. We're going to look at knowledge of content and students through common misconceptions, knowledge of content and teaching through instructional decisions and lessons, and knowledge of content and curriculum, how effective different methods are. So just kind of the best practices approach to teaching fractions. And when I'm talking about teaching fractions, I'm mostly going to look at fractions over decimals and percentages, even though they're all linked, just because of the time constraints and just to really focus on one area. So now we're going to move into the horizon content knowledge. So here we have the outcomes linked to each stage. In early stage 1, which is kindergarten, they describe 2 equal parts as halves. In stage 1, they are representing and modelling halves, quarters and eighths. Once we get to stage 2, we represent models and compares commonly used fractions and decimals. And in stage 3, compares, orders and calculates with fractions, decimals and percentages. So now we'll move on to the conceptual understanding in each stage. So in kindergarten, in early stage 1, they're establishing the concept of 1/2. So the emphasis is on dividing one whole object into 2 equal parts. Now let's have a look at a lesson example. So a great lesson example is this story here. Obviously a part of a lesson, Give Me Half by Stuart J. Murphy. And here's a page from one of the books. I have 1/2 pizza and 1/2 pizza make 1 whole pizza. So I'm a really big fan of mathematical literacy. It's been proven to increase engagement and mathematical discussion by providing a context to build conceptual understanding through the use of illustrations, language, and engagement. And if you have a look at the lesson resource for this session, I've actually linked book for each stages, so it's clearly there, and there's also links to Epic, which is a free site for educators, so there's lots of books that we can all use straight away. Now we're moving on to stage 1, conceptual understanding. In year 1, they need to recognise and describe one half as one of two equal parts of a whole, and in year 2, it's moving on to recognising and interpreting common uses of halves, quarters, and eighths of shapes and collections. Now to move on to a lesson example. Here we have 3 pictures. In the first picture, we're looking at what would be in the modelled and guided approach. It's important that we follow a model, guided, and independent approach. During the modelled and guided, the picture on the left can be shown with discussions of which one has equal parts, so you can kind of get a pre-understanding before you move on to the practical, more independent approach. And here we have students making fairy bread and cutting it into a half. So the first way you can show the different ways it can be cut into a half: vertically, horizontally, and diagonally. And then we have in the next picture, when they're moving on to quarters, you can show the different ways to make quarters. So it's all equal parts, and when you get children to share and cut food equally, it's amazing how very accurate they can be. Moving on to stage 2, conceptual understandings. In year 3, we're modelling and representing unit fractions, including halves, 1/2, 1/4, 1/3, 1/5, and their multiples to complete a whole. They're counting by quarters, halves, and thirds, including with mixed numerals. They locate and represent these fractions on a number line. In year 4, they're investigating equivalent fractions used in contexts. Recognise that the place value system can be extended to tenths, hundredths, and make connections between fractions and decimal notation. So that's when they're introduced to decimals there. And an example of a lesson is here. So we've got the equivalent fractions strips here. So what I like about this is it's a clear display of parts of a whole. The students partitioned the fractions, they've coloured it in themselves. It uses the bar method, not just a circular approach, which is more common, which we'll discuss more a little bit later when we move to misconceptions. So some ways I would improve upon this though is I would write the fractions and their equivalents. So the first one being 1/2, the second one being 2/4 equal 1/2, just so they can see the fraction notation written there and how it clearly links. Also, when we get to best practices, you can look at the use of grids or arrays, which promotes multiplicative thinking over additive thinking, which sometimes these methods can do. Now that we're getting into stage 3, please pause if you want to go into it more in depth, because I'm just going to touch on it because there's a lot more content. So compare and order common unit fractions, investigate strategies to solve problems using additive and subtraction of fractions, recognize that place value system can be extended beyond hundredths, compare, order, and represent decimals. And when we're looking at year 6, please also pause if you want to have a more in-depth look at this. So they're solving problems using addition and subtraction, they're comparing fractions, they're finding simple fractions of quantities, they're adding and subtracting decimals, they're multiplying decimals, they're multiplying and dividing decimals, making connections between equivalent fractions, investigating and calculating percentage discounts. Here we've got a stage 3 lesson example. So we've got the fractions, the equivalent decimals, and the diagram that represents the fraction in a bar model. So a way to improve upon this is they could also have the percentages there as well. Just looking at some of the specialised content knowledge, now we're moving away from the horizontal content knowledge. We're going to discuss language, because it's very important, especially being an EAL teacher. I work with a lot of students that don't speak English as a first language, and I find that some people have the misconception that there's not a lot of language in mathematics. However, it's very language rich, and we need to make sure we're always modelling the correct language. So teachers will extend their pupils' ability to learn mathematics by helping them to express their ideas using appropriate language, and by recognising that they need to use language in a way that is different from their everyday use. I'm just going to have now a look at what the curriculum recommends for each stage. Now we're moving on to a very important area for teachers, which is knowledge of content and students. So those common misconceptions that students have. Children focus on the size of the parts rather than their occurrence as part of a larger whole. So they have a weak part-whole knowledge, and we need to make sure that we're really establishing that. As I mentioned in the previous slide, language can be problematic. For fractions, a given number can have many names. It can be half, 5/10, 50%, 2/4, 3/6, 4/8, and it can keep going. So using language becomes a barrier. Another area that's quite difficult for students is specific versus general fractions. So specific is the actual quantity of these, and these quantities are different even though proportionally the fractions are the same. So an example of this would be a small pizza versus a large pizza. If you cut them both in half, proportionally they are both the same, being 1/2, but the halves are different. When you're looking at general fractions, the size of the whole is irrelevant and it's a more abstract understanding. So students are unable to distinguish between specific or general wholes. Furthermore, looking at problems with the whole, here you can see examples of the misconceptions of using different wholes can be seen in the diagrams that the student used when comparing the size of two fractions in the first one. The first question is, which is larger, 1/6 or 1/3? Draw the fractions to show which is larger. So they've correctly identified which fraction is larger. However, they've drawn different holes to represent this. So they've just drawn a bigger hole for 1/3, where they should have drawn the same size hole and shaded in 2/6 to show 1/3, so they don't understand the equivalence there either. In the second one, they put these fractions in order from the smallest to the largest, 1/4, 1/3, 1/5. Draw the fractions to show that your order is correct. So what they've done is they've just made whichever has the denominator has become the largest, and they've just kept extending on to the whole rather than dividing the whole up into more parts. And finally, you can see in the last one which fraction is larger, 1/4 or 1/3. Draw the fraction to explain how you know which is larger. We've got 1/4 or 1/3. 1/3 is bigger because cutting the circle into 4 pieces makes smaller bits than when you cut it into only 3. So that's a clear understanding of parts of the whole and partitioning. We also have problems with fraction notation, so incorrectly identify the number in each set as the denominator is what they end up doing. So in the first one, you've got 12 counters, and you ask the student how many blue counters there are. So they've partitioned it correctly, they've put it into 3 equal groups. However, they see the number in the group as being the denominator rather than how many group sets we have, because they're now seeing them as separate sets even though they are one whole. So they see it as out of 4 instead of out of 3. So back to problems with partitioning. Circular models that are often seen actually can contribute to misconceptions in partitioning when first learning about fractions. That's because students are exposed to fractions before they start learning about angles, and the circular model relies on the understanding of angles. And they're just using their understanding of length. And when they're partitioning it, younger students actually have a lot of difficulty to see how they are not equal shares. So approaches to teaching and learning. It's important that developing knowledge of the whole and the part-whole model in knowledge of content and teaching. So here we've got a diagram, and it's just taken from Australian Association of Mathematical Teaching. It is looking at teaching students that the whole can be numerous different sizes, shapes, so giving students different ones to fold the paper up and then compare it. And there's a little video here to watch the whole part meaning of fractions, but due to time constraints, I'm going to put a link to it on the slide so people can watch it. It's just a nice understanding of the whole part meaning for fractions. So approaches to teaching and learning, partitioning. So rectangles should be used first, not to rely on the understanding of lengths and angles. So in the first picture, that would be what you give a student once they've got a better, stronger foundation of partitioning. The first one would be much more capable for a student, much more reliable for them to be able to work out. So the variety of shapes should be used only once the partitioning is established. So the second one, providing squares or rectangles, is a much better approach. Here we have a poster that's made. So this was also taken from the Australian Association of Mathematical Teaching. So representing a range of fractions that demonstrate the whole can be a different size. General abstract fractions here. So just giving students lots of different pages to separate, and then they come together and match up to find students who have the same ones. And here they're looking at the different shapes, the different sizes, but how they still represent a half, and making a poster from that. And to introduce the fraction symbol, here's a nice representation. So we have ways to represent fractions. So 2/6 links to parts of a whole, parts of a set, strip diagram, so being the fraction bar, a number line. So I really like this poster because it's introducing the fraction symbol and showing how it relates to multiple different ways. How I would improve upon this, however, is I would have it clearly written what part's the numerator and which part's the denominator. And it's really important that we expose students to a variety of different fractions. So they should be looking at number lines, hands-on activities, partitioning, cutting things out, folding pieces. And finally, just to finish off, we have open-ended questions, and this really helps to push students, and those students that are working above gives them a bit of a challenge. So this is a picture from my Year 3/4 class 2 years ago. And one question is, a quarter of the fish are blue, what might this look like? And a third of the flowers are yellow, what might this look like? So as you can see here, we've got just above that sign, 5 out of 15 equals 1 out of 3. So 5 out of the 15 flowers are yellow, which proportionally is the same as 1/3. And I've got on my handout a few tips on creating some open-ended questions for fractions. Thank you very much, and I really hope that this was informative and that you've learned a lot.